This is chapter 4-2, Congruence in Triangles, part 2. Please copy your cuts. We're going to look at the properties of congruence for triangles. We've done these before. We've done these with segments, and we've done these with angles. Now we're going to look at congruence for triangles. Here's the reflexive property of congruence. And it says, for every triangle that is congruent to itself, it'll be triangle ABC is congruent. That's the congruent sign to triangle ABC. We did that back when we had segments or angles. Remember when we did the reflexive property, we said angle A is congruent to angle A. It was congruent to itself. Or when we did segments, we did segment DM is congruent to a segment DM. It was congruent to itself. We can do the same thing with triangles. So triangle ABC is congruent to itself. When it's congruent to itself again, it's still the reflexive property. Again, we've used it for angles. We've done it for segments. And now we're doing it for triangles. Triangle ABC is congruent to itself. That's Theorem 4.4. And now we're looking at the symmetric property. We did symmetric property again with angles and with segments. Remember with angles we did that. We did angle A is congruent to angle B. Then angle B is congruent to angle A. We switch them around. We can do the same thing here on triangles. If I have two triangles such that I have triangle ABC, and I say triangle ABC is congruent to triangle DEF, if it's symmetric, I can flip these around and now say triangle DEF is congruent to triangle ABC. We did that with angles. We also did this with segments. So it would be for segment AB is congruent to CD, and the symmetric will be segment CD is congruent to segment AB. Now we're just doing it with triangles. Triangle ABC is congruent to triangle DEF, and the symmetric says that the reverse, triangle DEF is congruent to triangle ABC. What I want to throw a quick pause in here is just to remember that when you do a congruent statement, each angle must be lined up with what it corresponds to. So angle A corresponds to D, so they're in the same position in the first place. Angle B corresponds to E, so they're in the second position together. And angle C corresponds to F, so they're in the third position together. Okay? That's just a throw right there. So if we did reflexive, symmetric, of course the third one would be transitive. And on the transitive property, we have here the three triangles such that we have triangle ABC being congruent to triangle DEF and being all congruent to JKL. Okay? And a transitive, remember, if the first and second are congruent to one another and the second and third are congruent to one another, then that means that the first and the third must also be congruent to one another. Let's look. For the transitive property, we have triangle ABC is congruent to triangle DEF, and first and third, so here's our first and second triangle. And then we have triangle DEF, the second is congruent to the third, JKL. So now the second and third are congruent. Then that means that the first and third have to be congruent. Triangle ABC, the first and the third are congruent. Triangle ABC is congruent to triangle JKL. And again, we always put vertices in the same spot that correspond to one another. So A corresponds to J, so they're in the both first position. Just like it's congruent to D, angle D, it's in that first position. Angle B corresponds to E and K. That means that those two will be in the second position as well. And finally, C corresponds to F and L on the other two triangles. Therefore, we see L in the third position, and on triangle DEF, we see F in the third position. Okay? All right, let's look quickly. Let's try this it's in your book. So please, 4.2, you can look at this example. We need to decide whether these two triangles are congruent. Triangle EGF and triangle JGH are congruent. Okay, again, EGF and JGH. Okay, and explain our reasoning. Well, when I look at this diagram, first of all, when I look at the diagram, I believe they're congruent because, number one, EF corresponds to JH. Notice how I said EF. I named E first, and E corresponds to J. I did not say EF to HJ because E corresponds to J, and I know that because F corresponds to H because both of them have the 58-degree marker. Okay? So EF corresponds to JH, and I'll write that for you. So EF is congruent to JH. And I write it in that particular order because we have here E corresponding to J and F, 58 degrees corresponds to H. Okay? And I also see that I have two more sides that are congruent. I see that EG corresponds to JG. And then I also see FG corresponds to HG. So three sides correspond. So here's my first portion of the statement. All three sides correspond to one another. And I also know that angles F and H correspond. They have the same values. And I know that angle angle G corresponds to angle G. And when I say angle G, I have to be specific because there's two angle G's. Angle EGF corresponds to JGH. And I know they correspond. Well, this angle E, before I go there, these two correspond because of vertical angles. So these two G values, EGF and JGH, correspond by vertical angles. And I know automatically that E and J will correspond and be congruent because of the third angle theorem. Okay? I already did G and G to explain that those two were congruent by vertical angles. I just wrote them in the opposite order. Okay? And again, E and J are congruent by third angle theorem. All right, and there's 4-2.